Hello and welcome everyone back for more biotechnology. So we have just one last topic for us to discuss in this chapter to round out our discussion on solutions in the biotechnology workplace, something that you're going to probably be doing very, very often, and that is making dilutions from already concentrated stock solutions. So practically speaking, this is the deal. So when large volumes of a solution that is not especially concentrated or needed often, it's not really going to be a good use of your time, nor is it going to be very convenient for you to have to keep making that solution again and again and again from scratch. You don't necessarily need to keep weighing out a certain amount of solute and bringing it up to volume. To get around this, you can make a very concentrated stock solution. So a stock solution is a solution that contains all the solutes you need, just at higher concentrations than what you are probably going to need. So the deal here is that you can just take your stock solution and dilute it down to get those solute concentrations down to what you actually desire. So in order to make a desired diluted solution from an already prepared stock solution, you would just calculate what volume of stock solution do I need to add to a certain amount of water in order to achieve the appropriate concentration of my particular solutes. So these sorts of calculations you can do with a fairly simple formula. C1V1 equals C2V2. So each one of these variables here represents a certain part of either the concentration or the volume of either the stock solution itself on the left side of the equation or the solution that you want to make on the right side. So C1 refers to the concentration of the stock solution, and this is going to be a higher concentration than C2, which is the desired concentration of the dilution you are making. V1 is the volume of the stock solution you are wanting to use, and then V2 is the total desired volume of the diluted solution. And V2 is going to be a bigger number than V1. You shouldn't need to take a whole lot of the stock solution in order to make a large volume of a diluted solution. So a note about concentration units here, since we've used several different values for concentrations in terms of things like molarity, grams per liter, mgs per mil, percentages, and things of that nature, you are free to use any concentration units that you want, but they have to be the same for both C1 and C2. You can't have C1 in terms of molarity and C2 in terms of grams per milliliter. And additionally, the volume units should be consistent as well. You don't want V1 to be in milliliters and V2 to be in liters. They either both have to be milliliters, both have to be microliters, or they both have to be liters. There cannot be any discrepancies in units here. So the best way to kind of get familiar with this is to practice it. So look at this question here. It says you have a stock solution of 200 milligrams per milliliter BSA. That stands for bovine serum albumin. This is a protein solution. And you want to make 50 milliliters of a 1 milligram per milliliter solution. So take note here, you want 1 milligram per milliliter. What you've got is 200 milligrams per milliliter. So what we're going to do here is we're just going to take a small volume of the concentrated stock solution and we're going to dilute it with water in order to get the concentration that we want. So to know exactly how much of the stock solution to take, we need to use that formula that we discussed. So the first thing we need to do is we need to calculate how much stock solution do we need. So C1V1 equals C2V2. We have all the information we need except for V1, which we are going to calculate here. So we know the concentration of the stock solution, which is 200 milligrams per milliliter, but we don't know V1, which is how much of that stock solution do we need. On the other side of the equation, we know the concentration of the BSA solution that we want, which is 1 milligram per milliliter, and we know how much of that solution that we want to make, which is 50 milliliters. So what we're going to do here is just a little bit of handy algebra. We are going to divide over the 200 to the other side of the equation here to end up with V1 equals 1 times 50 divided by 200. So that would give us a V1 value of 0.25 milliliters, or you could say 250 microliters. So in order to make this solution, you would draw up 250 microliters of the stock BSA solution into a P1000 micropipette, because that's the only tool we have to accurately dispense microliter quantities of liquid, and we are going to dispense it into a 50 milliliter graduated cylinder, and then from there we can bring the volume up to the 50 milliliter mark. So we need 49.75 milliliters of water. So at that point, we will have 50 milliliters of our 1 milligram per milliliter solution after we get it all mixed together. Okay, so let's get a little bit of more practice. This time, we're not going to use mass volume concentration. This time, we're going to use molarity. So this time it says, you make 75 milliliters of a solution at 100 millimolar by using 25 milliliter of stock solution. What was the concentration of the stock solution that we used? So we're going to use the same equation here, but what we're looking for and what we know is a little bit different than what we saw in the previous example. So again, we are going to use C1V1 equals C2V2, but our arrangement here is going to be a little bit different. This time we know everything except what was the concentration of the stock solution that we started with. So once again, we are going to rearrange things so that we get C1 all by itself on one side of the equation, and then it's just a matter of doing our order of operations here, 100 times 75 divided by 25, and you'll notice that the milliliter units will cancel out here, leaving us with just millimolar units, which makes sense because we're looking for a particular concentration here, and we want that C1 to have units of molarity here. So this tells us that the concentration of the stock solution must have been 300 millimolar. So we started with 75 milliliters of that, or excuse me, we started with 25 milliliters of that 300 millimolar stock solution, and by bringing it up to 75 milliliters in a graduated cylinder, we were able to achieve the diluted solution at 100 millimolar. Okay, let's do another one. This time it says, how would you make 50 milliliters of a 1x working solution of a DNA stain if the stock solution is 10,000x concentrated? So I think in a previous video I mentioned that sometimes solutions will be sent to you by companies at a particular X concentration. So they're not telling you what the molarity or what the grams per milliliter concentration is. They're basing the concentration on what you need it to be in order to work with it. So we want this concentration to be 1x. It is 10,000 times too concentrated is the stock solution. However, we can still use the equation the same as ever. C1V1 equals C2V2. So this time, the concentrations, we're just going to use those whatever x values. So 10,000x times V1, so x here in this particular example is not a variable for us to solve for, it's just part of the concentration, so don't get hung up too much on having more than one variable here. V1 is still the one variable that we are looking for. So 10,000 times V1 equals 1 times 50. So if we solve for V1 here, we get 0.005 milliliters, or 5 microliters. So if we want to make 50 milliliters of this 1x solution, we are going to mix together 5 microliters in about 50 milliliters of water to get our 1x working solution. So you have to beware once you get to volumes that are getting into the single-digit microliter range, you have to be careful because you'll remember once you get below half a microliter, there is no micropipette that can accurately dispense anything less than that. So 5 microliters is starting to get kind of towards the bottom of what we can accurately measure and dispense. All right, so that is going to do it for Chapter 3. I congratulate you on getting this far, and I hope you will join us next time when we start talking about DNA structure and function in Chapter 4. And we'll start talking about some neat biotech applications for how to work with and how to study DNA. So thank you for your attention, and I will see you next time. Bye-bye.